continue and moving on to the next speaker in our medical AI session. This presentation is more mathematically focused, and I'd like to give the floor to Oleg. Oleg, you have the floor. Good afternoon. I hope you can see me well, dear colleagues, and see my... Well, I will begin my presentation. Thank you, if you can hear me. Good afternoon. My name is Oleg Kachan. I'm a PhD student of Skoltech Institute of Science and Technology. Geometric methods AI-based neuropsychiatric diseases diagnosis is the name of my presentation. Developed using the genetic structure for such types to detect cognitive impairments. Let me outline the job. Early stages of Alzheimer's disease are marked by cognitive impairment diagnosis, loss of space orientation, falling cognitive function result in early dementia. Using therapy, we're able to slow down the impairment of cognitive functions and associated diseases, and accordingly development of these diseases to later stages, to more serious stages. Problem with the AI-based method is low accuracy and reproducibility due to small size and noisy nature of medical databases. But since dementia affects brain functions, this data can be extracted from MRI imaging. However, AI technologies may not provide enough sensitivity and specificity and the noises across time. So the mathematic method of smoothing the noise and leveling allows us to improve this MRI diagnostic imaging processing. Let me tell you more about MRI and about what this type of data represents. MRI as a brain functional MRI, as opposed to normal MRI, just measures the brain to detect pathologies such as cognitive impairments. This provides fMRI, provides 3D imaging across time series. Voxel time series also provide the measurements for brain activity at any given point. Let's look at the fMRI data analysis pipeline. Since they have quite large size, a few hundred voxels, they're collected in series, which define separate parts of the human brain, and the connectivity matrix is then compiled, describing the brain connections. Machine learning algorithms are used then, and symmetric positive definite network N by N is used. All the own values of these matrices are strictly above zero. At the final step, the connectivity matrix is fed into machine learning algorithms to provide for classification. And the matrix is positive certainty. We can improve machine learning on small panels by narrowing the search space using such matrices with intrinsic geometry. We propose smoothing the WRT matrices, data smoothing. For each matrix X is smoothed matrix X is a linear combination of X with matrices from its neighborhood with properly selected weights. Proposed to select weights according to the intrinsic geometry of the space of symmetric positive divided matrices, providing for the needs of classification. This method was tested at the open-based ASIS-3, which represents data from fMRI of over 1,000 patients of various ages. Out of the 605 adult participants of the control panel, 493 panels suffering from early-stage AD dementia. or those caused by Alzheimer's in early stages. This data was used, processed was used from 3 MRI scanners. OASIS 3 data set benchmark for the early stage cognitive impairment, 3 time series, functional atlas of the human brain. The results 3 to 10% increase ROC AUC compared to MRI, higher quality with a rougher breakdown. Now let's look at the geometry of the space of positive definite matrices and the methods used in our work. The space of these positive definite matrices are all the matrices containing own values strictly above zero, and this space is also called the cone of positive definite matrices. The geodesic distances differ from those we are accustomed to. The lines, straight lines, can overlap, and the shortest distance between 2 points lies in the curve, the so-called geodesic distance. For such spaces, the job for mean-weighted share down to optimization solved through iteration, Riemannian gradient descent by weighted sum total of the root squares. Equivalent solution can be described as exponential logarithmic maps. Here you see the equation lower. Conclusions. Our report presented this new geometry-motivated data smoothing method, which takes into account geometry of space-symmetric positive difference, showing the substantial increase of accuracy of the early cognitive impairment diagnosis task based on fMRI data. And the method is general and could be used in other imaging modalities, EEG, MEG, echo, and others. Also was used for early-stage Alzheimer's patients and early cognitive impairment. EEG, MEG, ECOG, and other time series can also be used. Thank you very much. I'm ready to take your questions. Oleg, thank you for your presentation. I had a question regarding other modalities, but you already answered that. So out of the technologies you listed, are you expecting any of the approaches to bear fruit and make it more generalized? Well, yes, we are planning a more generalized application of our approach for other test panels and possibly to using it on partners' real data from hospitals and other healthcare institutions. Thank you. Very well. Thank you. May we have a question? Yes, please. I may have missed it. So you do have a connectivity matrix, and then how do you select this matrix in the neighborhood? Do you accidentally do you randomly take epsim neighborhood? Well, if we use the intrinsic geometry for spacing these matrices, this allows us to better improve the smoothing of the matrices. So the distances between the two, if we look Euclid's distances, if we look at the matrices across vectors, will provide the answer as to which matrices will lie in the neighborhood. And this is not fully correct, because if we're on the Earth's surface, on the surface of a full sphere of a circle, we can provide a more precise reading of distances across the curves. So if we take something from the neighborhood according to the matrix, intrinsic matrix, it will be better than using simple spatial matrix. Okay. Colleagues, thank you. I think it's quite gladdening that the format had moved on to such a live debate and discussion. We're missing this live communication format.